Hi, this is Chemical Kim, and I'm going to go through some practice problems with you in Unit 7. I thought it would be best to work on the mixed stoichiometry problems because I know that we haven't tackled those. I've gone through doing stoichiometry problems on other videos, but when you have them all mixed together, it can be a bit more challenging. So I thought this would be a good place to look at with tackling the practice problems in Unit 7. So I'm going to start here with number 38. I do recommend while you're going through this with me, not only have the practice problems in front of you, but also have a calculator and maybe on a little sheet of paper, list out this little schematic because I think it's a helpful guide while tackling stoichiometry. And I'll be utilizing that as I set up the problems and guiding myself as to what steps I'll be taking. Okay, so anyway, with that, let's look at practice problem starting with number 38. We can clearly see with number 38 when it says how many moles of chlorine gas, which is of course a diatomic, so that's why it says Cl2, would react with 5.0 moles of sodium according to the following chemical equation. So we can clearly see that we have to balance the equation first. And looking at the equation just in terms of, ratios, we have the 1 sodium on the reactant side, the 1 sodium on the product side. We have the 2 chlorines on the reactant side and only 1 chlorine on the product side. So I have to put the coefficient 2 in front of the NaCl, and then I'm going to put the coefficient just 1 in front of the Cl2 because that will keep my Cl's balanced, but because my 2 unbalanced my Nas, I'm going to put a 2 in front of the NaCl2. Okay, so I also like to, based on the question that's being asked and what is given, I like to circle the 2 materials that I'm going to be doing stoichiometry on in the equation, or in the question. So because it says how many moles of chlorine gas would react with 5.0 moles of sodium, I circled the chlorine gas and the sodium, and those are the 2 that I want to focus on. Also, referring to the schematic, I am actually starting here in the mole box because I'm given moles, and I'm going to end here in the mole box because moles is being asked. So I'm basically doing a mole to mole calculation. So in the 3 steps of stoichiometry, I'm only doing step 2. So let's work on that. Okay, so to set up the problem, and I encourage that you look at setting the problem up mathematically, it would look like this. I would take my 5 moles of sodium, that's what's given, and I'm going to put that over 1. And I'm going to do the railroad setup that I've shown in class. And the ratio from the chemical equation shows a 2 Na to 1 Cl2. So I would put in the setup 1 mole Cl2 on top and 2 mole Na on the bottom. Okay. Now I also have my calculator just to show you how I calculate this. I simply type 5 on the calculator and then times, and I'm going to put in parentheses that ratio, 1 divided by 2, just like that, because that's what that calculation involves, is taking 5 times 1 divided by 2 and hitting enter and keeping significant figures. The answer is 2.5 mole Cl2. So that's just a simple mole-to-mole calculation. Okay, and of course, like I said, these are mixed stoichiometry problems, so it's a question of like, what do you start with and where do you finish? So having that schematic, that 3-step schematic handy to refer to can be really helpful. So let's look at the next question. So the next question says, if you start with 10 grams of aluminum hydroxide, how many grams of water will be produced? Well, the nice thing is that this equation is actually balanced for us. So again, I'm going to do a little bit of circling or highlighting. And the question starts with, let's see, if you start with 10 grams of aluminum hydroxide. So I'm going to find in the chemical equation that aluminum hydroxide, which is right here, the AlOH3. Now keep in mind that if there's no coefficient written with that formula in the balanced equation, the coefficient really is 1. It's not 0. There is actually a 1, and I do like to write that 1 just to let you know there is a number there. Okay. And then it says how many grams of water. So the question that's being asked is grams of water. So I'm going to look in the balanced equation and locate my grams of water. So those are the two that I'm going to be focusing on in doing this calculation. Going to the schematic, seeing that I'm given grams and I need to find grams, on the schematic for steps, I have to do all three steps. So I'm going to start here in the gram step, and then I'm going to finish here in the gram step. And so that involves the 3 steps of stoichiometry. My first step, going grams to moles of my start material. I'm going to divide by the molar mass, and then I'm going to do the bridge step, going moles to moles. And then the third step is to go moles to grams using the molar mass of my what I'm trying to find material. Okay, so let's tackle that. Let's do that in the setup in this calculation. So I'm going to start with my 10 grams of aluminum hydroxide. Oh, forgot to also mention what can be really handy in doing these calculations, of course, is the periodic table for calculating molar masses. Now, if you want to utilize the EMD app, as we've used in class before, right here for helping in saving time and doing molar mass calculations, that would be clicking on the menu option, clicking on molar mass calculator, and typing in the formula AL and then parenthesis OH2, or actually it's 3, and then equal, and that gives me that molar mass that I could use in the calculation. But for this particular calculation, I'm going to take you through the steps just to remind you of how to do molar mass calculations. Okay, so starting with 10 grams of aluminum hydroxide. So I take my 10.0 grams of my AlOH3. Okay, and again, I'm going to put that over 1. Here in this first step, I'm going to divide by the molar mass. So I'm going to bring up the bring up the periodic table, and using my calculator, I'm going to look at taking that aluminum. Okay, so let me clear my calculator here, and I'm going to type in 26.98, and I'm going to add that to looking at hydroxide, and there's 3 of them, so I have to take the 6.00 for oxygen, because I'm rounding all the atomic masses to 2 places after the decimal. I'm going to multiply that times 3, and then I'm going to add that to the hydrogen, which is 1.01. Again, that times 3, and I get 78.01, which was very close to, if not the same here, just off because of the carrying of the atomic masses, but pretty close to what my molar mass calculator gave me. So 78.01 I'm going to utilize because I did that by hand. So I'll put down here in the denominator 78.01 grams. And that is, here I'm going to use a smaller marker here so I don't, let me change the marker size right there. Okay, so that would be grams of AlOH3, and I'm going to be putting that over 1 mole. Okay, so that's my first step. That's the first step here in the 3 steps of stoichiometry. And then the second step is to do the bridge step. And that's where I refer to my balanced equation. And I'm just going to add on to my railroad as I do the bridge step, step 2. And from my balanced equation, I see that my ratio is 1 AlOH3 to 3 H2Os. And because I'm going to the water, I'm going to put that 3 on top, and I'm leaving the aluminum hydroxide, so I'm going to put that 1 on the bottom. So in the ratio, I'm going to put 3 mole H2O, again, that comes from the balanced equation, and then 1 mole AlOH3, and there's my mole ratio. Now, if you kind of pay attention here, what you're also seeing is how units cancel. So by setting it up by the railroad, that first step, the grams of AlOH3 cancels. And if I were to make sure I indicate this is AlOH3 here, that also cancels the mole of AlOH3. So now I'm here at the second step. After I do the calculation, it puts me here at the end of the second step. I just did that bridge step. So now I'm going to do the third step of stoichiometry, which is to multiply by the molar mass. And in this case, I'm going to be multiplied by the molar mass of water. So I'm going to now put on the top of my bridge here the molar mass of H2O, which I think many of you already know by now. We've worked with water so many times, but again, I'll still calculate it using the periodic table. I'm going to take my 1.01 for hydrogen, multiply that times 2, and then I'm going to add that to my 16.00 for the oxygen. So I have 18.02 grams per mole for the molar mass for water. So I'm going to put that here, 18.02 grams of H2O, and then 1 mole of H2O here. And that will give me the molar mass for water. Again, seeing how my units cancel as I go along with each step. I'll minimize that so you can see all of that. And now I calculate. Now I'm going to explain how I put everything into the calculator. You can hit enter after each calculation, after each step, or you can just kind of put it all in the calculator at once, keeping in mind what is up on the top gets multiplied, what is on the bottom gets divided. So I'll do each step at a time. You can kind of see how it goes. So let me clear the calculator. I'm going to type in 10.0, and then I'm going to hit divide, and then type in 78.01, and I'm going to hit multiply. Oh, wait, I said I would hit equal after each step. So the first step, I end up with 0.128 moles of AlOH3. Now I'm going to bridge that, so I'm going to hit times, and then that's that ratio, 3 divided by 1, hit equal. Okay, so that's the answer to the moles of H2O. And now I'm going to multiply times 18.02. I could hit divide by 1, but you know that's going to be the same number. And I end up with an answer to this calculation to being 6.92 or 6.929. I'll round that up. Whoops. I think in the answer key I have 6.92, but again, I hand calculated the molar masses, didn't carry all the values out, so it can vary, and that is, of course, grams of H2O. So our numbers are pretty much the same as 6.93 or 6.92, depending on how far you carry your molar masses. Okay, let's try the next one. Number 40. If you start with 4.500 moles of ethylene, which is C2H4, how many grams of carbon dioxide will be produced? And again, the equation is all balanced, which is fantastic. So I like to, like I showed previous, I'm going to highlight what I am given, which is 4.500 moles of ethylene, and then I'm going to highlight that in the balanced equation, keeping in mind that if there's no coefficient written, that the coefficient is 1, because I'm going to be using that in the bridge step. You'll always be doing the bridge step in stoichiometry, which is that second step, using the balanced equation. And then the question is, how many grams of carbon dioxide? So what's being asked is grams of CO2. And I'm going to locate the CO2 in the balanced equation, which is right there. Now going to the 3-step schematic, let me bring that up, okay, and let's see where we're going to start and where we're going to end. This kind of maps out my steps. Well, going back to the question, I am given moles. So if I'm given moles, I'm going to start at the mole step. And then I need to determine the gram quantity. So since I have to find grams, I'm going to end in the gram step. So let's look at that. So I'm going to start here in the mole box, and then I'm going to end here in the gram box. That indicates that I would be doing The second step, just so you know, this would be step 1, this would be step 2, and this would be step 3. So I'm just doing steps 2 and 3 in the 3 steps of stoichiometry because I'm starting in the mole box and I'm going to end in the gram box. So let's set that up in the problem. Okay, so starting in the mole box with my, and I'll write that out. Let me make that a little bit larger so I don't have to squeeze it in there. So I'm starting with the 4.500, just for the sake of significant figures, I'm going to include all those zeros, mole, and I do indicate what that is, C2H4. It helps me keep track of my material, okay? And again, I'm going to put that over 1, build my bridge, and in this first step of stoichiometry, and if I need to refer to the step, I see that it is the bridge step. So I'm going to set up the bridge step using the balanced equation. The bridge step, which is step 2, is always using the balanced equation. So starting with moles, and my balanced equation says my ratio is 2 moles CO2 to 1 mole of the C2H4. So that's how I'm going to set it up in the calculation. I'm going to put 2 mole of the CO2 on top, 1 mole of the C2H4 on the bottom, and then that allows my moles to cancel, and then I'm going to go to the next step. So that tackled step 2 in the 3 steps of stoichiometry. That put me here in the mole box right there, and now I get to go from the mole box to the gram box by multiplying by the molar mass. And you notice how in my setup, I do indicate my material. So it is the molar mass now of CO2 that I'm going to do in this step. Okay, so calculate the molar mass of CO2 using the periodic table. I'm going to take 12.01 for carbon, and then I'm going to add that to 16.00 times 2, which is of course 32. And I get a 44.01 grams per mole for CO2. So that's the number I'm going to use here, the 44.01 grams CO2 over 1 mole CO2. And I like to see how my units cancel. So in this case, my mole CO2 cancels. If you notice in that railroad, if they're opposite from each other, they cancel out in units. Putting this into the calculator. Again, I'll do each step on the calculator so you can see that, and you can see the answers and the final answer. Okay, so first I'm going to type in 4.500, and then I'm going to multiply that by that bridge step, that 2 divided by 1 ratio in that bridge step. And from that, I get the answer 9. And then I'm going to take 9 and multiply that by 44.01 divided by 1, which is, of course, the same number. And I get an answer, and it's a really large answer, but it is the correct answer because you're basically taking 9 moles times 44. So we have 396, and the answer would be grams CO2, just like that. Okay? So let me tackle a couple more here, and then I'm going to do another video lesson on doing we're not doing limiting reactants, but I'll be doing percent yield calculations and theoretical and kind of explaining what that is all about. Okay, so number 41, let's take a look here. If you start with 5.5 grams, again, I'm going to highlight that given 5.5 grams of NaF. And I'm going to locate that in the balanced equation right there, the NaF. And then it asks how many moles of magnesium fluoride will be produced. So I'm going to locate the magnesium fluoride right there. There's no coefficient in front of it. So again, I'm just going to put the number 1 because that would be the coefficient if there's nothing that's shown. Okay, so let's look at the schematic and see the steps that we have to take to do this calculation. We are starting with the 5.5 grams of NaF, and then we want to find moles of MgF2. So we're given grams, we want to find moles. So let's look at those 3 steps here on our schematic, okay? So with that, we are going to be starting here in the, now I have to go back because I had to clear that up. Okay, so we're going to be starting in the gram box, and then we're going to end in the mole box. So we are going to start here in the gram box, and then we're going to end here in the mole box. So the way the schematic works is you're either going to start in one of the top two boxes, and then you'll end in one of the bottom two boxes. So given grams, we're starting the gram box, and then needing to find moles, we're going to end in the mole box. So in this, we're going to do the first and the second step in the 3 steps of stoichiometry. Okay, so let's tackle that. So first step is, according to our little schematic, divide by the molar mass. And of course it's NaF because that's what we're given. So we're going to start with the 5.5 grams of NaF. Okay, I'm going to put that over 1, build my bridge. And if we divide by the molar mass, after I do the molar mass calculation, I'm going to put that molar mass down in the denominator on that bridge step. So let's bring up the periodic table. And this is an easy calculation because it's just simply 1 Na. And Na is 22.989. I'm going to round that up to 23.00. And then, oh wait, actually, let me clarify. Let's put that, I can carry it to 22.99 because I can round that 8 to a 9. So 22.99, and then I'm going to add that to fluorine, which is 18.998. This one I would have to round up to 19.00 if I'm going 2 places after the decimal. So I end up with a 41.99 for its molar mass. So 41.99 I'm going to write here, and that's grams of NaF. I like to list what the material is, and 1 mole of NaF. Because the molar mass is just simply NaF. I'm not converting between 2 materials, but I will be doing that on the next step. Okay, so my grams of NaF cancel. Now I'm going to move to the bridge step. And that bridge step is going from NaF to MgF2. And as I explained in a previous video, to do the bridge step, you put on top of the bridge what you're going to, and then on the bottom of the bridge what you're leaving. So since I'm going to MgF2, I'm going to put 1 mole MgF2 on the top, and then I'm leaving NaF, and the coefficient in front of the NaF in the balanced equation is a 2, so I'm going to put 2 mole NaF on the bottom. Okay, so that's how you set up that bridge step. Now, I do want to mention, I'm not going to add another link to this. This is where I end because I'm ending at the mole step. Okay, so I'm only doing step 1 and step 2 of the 3 steps of stoichiometry because moles is what's being asked. So bringing up the calculator, again, I'll kind of show you here too how units cancel. So bringing up the calculator, I'm going to take my 5.5 and I'm going to divide that by 41.99. And that gives me 0.130, and that is moles of NaF. Now I'm going to multiply that times that ratio, 1 divided by 2. Now I could simply have just divided by 2, but with that mole ratio, I like to kind of show that in that fraction when I put that into the calculator. Okay, the answer, keeping significant figures, and I was starting with 2 significant figures, so I'm going to put my answer to 2 significant figures, 0.065, and that would be mole of MgF2. Just like that. Okay? So I'm going to do one more, and then you see the ones after that are the theoretical and percent yield calculations, which I will explain and give you more insight as to that. And then I'll also look at energy put into a chemical equation. So here we go. We can do this. Number 42. Let's look at the question. If you start, so on number 42, we're starting with 20.0 grams of hydrochloric acid. Hydrochloric acid, remember that hydro means it's hydrogen with just a single nonmetal. In this case, it's chloride. So we're going to find that right here in the balanced equation. And then how many grams of sulfuric acid, no hydro, so it's hydrogen with sulfate, that polyatomic, so it's H2SO4 there's our H2SO4. So those are the two that I'm going to be going between on my stoichiometry calculation. And you can see I'm given grams, and I'm going to have to find grams. So in this, I'm starting in the gram box, and I'm going to end in the gram box. So I'm doing all three steps of stoichiometry. Given grams, find grams. Okay, so this should be a big calculation. Let's do it. So let's start with our 20 grams of HCl. 20.0 grams of HCl. And I'm going to put that over 1, build my bridge, and divide by the molar mass of HCl. So let's bring up that calculator, molar mass calculator, or I'll do it, traditional with just adding up the atomic masses. So I'm going to take my 1.01 for hydrogen, and then chlorine, 35.45, and I get 36.46 for that molar mass. So I'll put that into the calculation, 36.46, and that's going to be gram HCl to get that unit to cancel, and then 1 mole HCl. Again, see how I label. It does take a lot of work, but labeling can really help prevent making the mistakes in terms of where you're at with each calculation. So that is step 1 in the 3 steps of stoichiometry. And that first step allows that gram HCl to cancel. Now let's go to step 2. Step 2 is the bridge step. Again, I put on top of the bridge what I'm trying to find, on the bottom of the bridge what I'm leaving. What I'm trying to find is the sulfuric acid. In the balanced equation, the coefficient in front of the sulfuric acid is a 1. And I'm leaving the hydrochloric acid, and in the balanced equation, the coefficient in front of the hydrochloric acid is a 2. So I'm going to set up that ratio. I'm going to put 1 mole of the H2SO4 on the top and 2 mole of the HCl on the bottom. Again, those numbers come from the balanced equation, that ratio with those coefficients. And it does allow my HCl unit to cancel like that. Okay, there's the second step in the stoichiometry. Now we're moving on to the third step, which is a molar mass calculation again, but in this case it's for the H2SO4, which is not that. It's a little bit bigger than the HCl, but it definitely is something we can calculate. So let me bring the calculator up again. Let me bring up my periodic table, H2SO4. So I'm going to start with 1.01 times 2, that's for hydrogen. And then I'm going to add that to sulfur, because there's 1 sulfur, not 4, but 1 sulfur in the H2SO4. And sulfur is 32.07, rounding that up to 2 places after the decimal. And then I'm going to add that to, starting my parenthesis, because I'm going to multiply. So I'm going to take 16.00 times 4. So if you notice in the calculation, because I have 4 oxygens, I have to multiply that by 4. So the molar mass of H2SO4, 98.09. Okay, so putting that into the calculation, I'm going to put 98.09 grams of H2SO4 on the top, 1 mole H2SO4 on the bottom. That allows my moles to cancel of H2SO4, and I calculate this out. Okay, so let me put all of this onto the calculator. So clear the calculator. I'm going to type in 20.0, and then I'm going to hit divide 36.46, and I get 0.5485 moles of HCl. Now I'm going to multiply that times the ratio, which is 1/2. And I get now 0.274 moles of H2SO4. Then I'm going to hit times the 98.09, and I get 26.9 for the final answer. And I think in the answer key I have 26.0. That again could be a molar mass. It shouldn't be that far off, so maybe I have a little error in the answer key. Or I made hopefully I didn't make an error on this calculation, but I would probably double check and see But that is basically the 3 steps of the stoichiometry calculation. So not too bad. Again, I'm going to post another video with doing percent and theoretical yield. Hopefully you'll see it's not too much more difficult, just doing some more stoichiometry. So I hope this helps. Don't stop here. Definitely have some more practice problems on stoichiometry all through these next few pages. Give them a try. Some of them you have to balance the equation. But please let me know if you need additional help and you're still really, working through this. But utilize the videos I've posted, and hopefully this one can be an addition. Okay, good luck.